Everybody, with ChatGPT and GPT-3 and AI in general back in the news, I wanted to touch base briefly about the news and the coverage we've seen coming out regarding these deep nets. For a bit of background, obviously, academically, I was trained as a social scientist. I mostly worked on China and Russia's international relations, international policies. But in my professional life, I actually ended up through a series of I don't know if unfortunate events is accurate, but a series of events, a series of events landed me as a data scientist and a machine learning engineer, mostly working to apply natural language models to data. So while I would never pretend to be on the level of a Jan LeCun or someone like that, I'm not writing the math, right? I'm not writing the equations that underlie these types of models. I do have a lot of experience training them, understanding how they work, customizing their hyperparameters and things like that, and maybe most importantly, getting the data ready to train and test them. And the most recent coverage we've seen really has been about the ChatGPT model passing the Turing Test, right? This is what often happens in the mass media coverage. The Turing Test is often thrown out as a really important landmark or goalpost for these models to reach. So today I wanted to talk a bit about why that's not really how machine learning engineers think about the Turing Test, and probably not how you should think about it either. So why is the Turing Test a big deal, but maybe why is it a big deal in a way that might be different than we think? And to answer this question, we really need to, I think, first understand what the Turing Test is. So the Turing Test obviously isn't a test. It's really more of a game or a thought experiment. It's one of these interesting ways of thinking about machines and humans and intelligence, right? It emerged out of really obviously the work of Alan Turing, who was a visionary and genius, and this is a person who really helped defeat fascism. And obviously, I would encourage everyone to look into his personal story. It's also a fascinating story about LGBTQ representation and bigotry and the freedom to be yourself. And I would recommend reading into his life story, both to see the bravery of this person in the face of cultural bigotry, but also his resilient genius. And also, I think to see the negative impacts of what this kind of bigotry does to people at a human level. So what is the Turing Test? What does it do? The Turing Test, again, is not a real test. It's a thought experiment. Turing was curious fundamentally if machines could think, right? This is sort of the grand idea behind this. Can machines think? And so what he proposed was really a judgment call made by our best interlocutor, right? Our best example of a thinking thing, which unfortunately is us. In this thought experiment, this test, you have basically an observer who is a human sitting in a third position to two other actors, and one of those actors is another human and one is a machine. And the basic idea is that there's a conversation, generally a text conversation happening here, and there's queries and answers going on. If the human observer cannot reliably distinguish, let's say better than random chance, between the machine actor and the human actor at a better than random chance, the machine actor is said to have passed the Turing Test. So importantly, this test is not actually a test of intelligence, right? It's a test of the machine's ability not to give correct answers, but to give answers that resemble the answers that a human being would give. So I'll throw up on the screen here a recent PC Guide article that really kind of reaffirms a lot of the problems in how we cover the Turing Test in mass media. We can see a common misunderstanding here on what the Turing Test actually is. So in the PC Guide example here, you can see this common misunderstanding, right? That the Turing Test is about measuring intelligence when it isn't about measuring intelligence. What Turing had at best here was kind of an intermediating variable for intelligence, right? And what it really measures is not intelligence, but the ability to mimic something that we suspect to be intelligence. It measures the ability of the algorithm to mimic a human being. And importantly, and kind of surprisingly, if you look into this, there's actually been several examples in the past, going back to the 1960s, where algorithms have been said to have passed this test. Famously, there was an algorithm, I think in the mid-60s, called ELIZA. I don't remember what ELIZA stands for, but it was a much cruder model than what we have in today's deep language models. It was essentially a series of heuristic rules to respond to questions with other information, or kind of respond with a question. And I think there were also some kind of complex other heuristics about keywords, and if those keywords were in the human user's query to ELIZA, it would return a transformation of their original query to sort of appear intelligent. And ELIZA was put in front of groups of people, and actually it ended up convincing quite a few of them, I believe more than half, that it was they couldn't distinguish between ELIZA and a person, and they were actually some of these individuals were quite difficult to deconvince, right? They really believed that this thing was a person, and they had trouble believing that it wasn't. And this is a good entree into why this isn't the greatest test in the world, right? It was very much ahead of its time in the 50s, early 50s, when it was developed as a thought experiment. But one of the biggest problems with it is exactly what we see with ELIZA, right? With ELIZA, the problem is the naivete or the misunderstanding or the lack of information that the observer, the human observer, has about the state of technology at play can be very important in determining or passing this test. If you put yourself in the shoes of somebody in 1966 and you're presented with this prompt-driven ELIZA algorithm and you are fooled by it, you could imagine that somebody from today's world would not have that same experience. They would be more skeptical to the ELIZA algorithm. And this is an important critique of the test because it shows us that knowledge about the underlying algorithm technology actually impacts that threshold to pass the test, which in science we would say makes it not a great test. So the rubric to pass the test changes as our information about the underlying algorithmic technology changes. So what? This is sort of a scientific quibble, right? It's not a real critique. Interestingly, I think what this signifies about our understanding of intelligence is also quite interesting, right? That the bar for what that entails keeps changing. So not only is the test bad, we can start to subjectively criticize our own definitions of intelligence, right? And our own delimitations on what is or isn't intelligence. So now that we understand the Turing test is really about mimicking human intelligence, we can see another critique of it, which is that not all intelligence needs to be human. You can easily imagine other types of intelligence that aren't human. Accordingly, you can also, thanks to people like Marjorie Taylor Greene, imagine human beings that aren't intelligent themselves, right? So you sort of have two circles that kind of overlap in the middle, where some human behavior is intelligence, some humans are intelligent, but we can also imagine a completely different circle in the Venn diagram of whales or octopi or aliens or, non-silicon-based life forms or whatever one, you can imagine a machine intelligence, right, that wouldn't necessarily comport or comply with the type of intelligence that's demonstrated by greater apes. Relatedly, the Turing test is fundamentally a language-based measurement. And we know even within human beings that there are intelligent people who are not verbal or who cannot read or write. Another critique is a bit more philosophical and I think psychological, and this is that the Turing test sort of by definition has to be what we think of as behavioral or functional. It's concerned really primarily and actually kind of solely with the way that the algorithm acts. It doesn't have a way of pointing to or feeling out the underlying process by which that action is generated. Because of this behavioral or functional approach to the study of mind, we can't actually tell if the machine is thinking, right? We can only tell that it's simulating thinking. And frankly, with these kinds of deep neural networks trained on billions and billions of items of human knowledge, we shouldn't really be that surprised that simulation of our thinking is possible when we start to look at what we'd call the corpora, the training data that these things are built on. So with these critiques in mind, obviously we need, as we go forward, to have a better understanding of consciousness. How do we define it? How do we think about cognitive humanhood versus just mimicry. And I think this is where the Turing test is still useful, right? It's a starting point, but it's not an ending point, because we need to think about things like, how do you make logical inferences? How do you have inherent intention in your answers? Features like empathy or caring. These are concepts that seem soft, but they actually fundamentally belie an ability to distinguish subject and object, or actor and external, right? These are things that show the ability to see the self and to put oneself in someone else's shoes. These kinds of things are deeply indicative of consciousness. But I think we can all agree that intelligence needs to be assessed at a deeper level than just, can you trick an observer who may be completely ignorant on the state of algorithms in the field. So then what is ChatGPT, or the underlying model GPT-3? What are these things? How do they address the Turing test? And why does this all matter? And this is where the video gets hard, because I have to explain ChatGPT in like 3 minutes, right? I'll look at my notes. I'll look at my notes here and say the architecture of ChatGPT is a decoder-only transformer network with a 2,048 token long context and a size of 175 billion parameters. Okay, what? This basically indicates that there's a large range for the tokenization. Tokenization is really how the text is transformed into vectors that the algorithm can digest. This is really just converting the strings that we use as humans to a machine-readable format. And then the parameters, this is a bit of a nebulous definition sometimes, but this basically means all the weights and biases within the model. You can think about it as a series of nodes connected by weights and biases that ultimately discriminates between different classifications often. There's different ways to use it, but let's say for the sake of argument, we're talking about classification here. So the parameters are just all the things that the algorithm can modulate and can change over time to fit the input value to the output value. And this is done through a process called backpropagation. And this happens, billions and billions of times. And you can imagine over time, if you want to distinguish between a picture of a cat and a dog, and you give it many, many labeled examples, it's going to figure out the details of those weights and biases that correspond to that. One of the many things that's cool about these deep language nets, is they start to have the ability to do what's called one-shot or few-shot learning. And this is really at the core of some of the innovation here, right? Is that you can imagine it's somewhat trivial to imagine a model that could take billions of inputs and learn the encodings within them, right? Learn the weights and biases that correspond to one input to one output. What's a cat look like? What's a dog look like? What's cool about few-shot learning, and I'll keep using the image example for the sake of simplicity, although in this context with ChatGPT, obviously we're talking about language. But what's cool about these models is that in this few-shot learning, what they can do is generalize their information. So if you've trained it to distinguish cats, dogs, and horses, and then it sees a zebra, right? The few-shot learning principle would indicate that it isn't just memorizing to the categories that you've given it. It's also going to assign, a probability to that zebra that says this is closer to a horse, right? I don't know what it is, but it's closer to a horse. And this gets to a really cool concept in science that we call generalizability, right? You want to have a model, you want to have a theory of the world, or a theory of anything that can apply to both things that are kind of exactly what they should be, but also things that are slightly different, right? An intelligent actor would see a three-legged dog and say that's a dog, right? But a model that's overfit, that's too tightly constrained to just dogs, wouldn't have that ability. So this is one of the cool things about ChatGPT, is through a lot of hard work and a lot of clever programming, it's actually able to answer questions that it hasn't seen exactly before. It has an idea, let's not say an idea. It has a concept of questions that are similar in sort of its embedding space to questions that it has seen before. So it doesn't need to have seen it exactly in the past to give an answer, which is really cool. And again, this gets us closer and closer to this answer to the passing of the Turing test, right? If it can have this sort of human-like ability to discriminate or distinguish between categories of things that it hasn't quite seen before, this is something we, as human beings, really, we can connect with, we can empathize with, we can understand. We expect this from an intelligent actor. But again, it's mimicking that action. And it's doing it based on billions and billions of rows, and it's also doing it based on something called reinforcement learning from human feedback. This is another complex kind of side model that really gets some incentives and some weights and some behavioral little carrots from human supervision. And this reward model is kind of an adjunct, or it sits on the side like a little vestigial remora fish, and it's given, it kind of updates its rankings and outputs given human feedback. So not only is the training data for something like ChatGPT really all-encompassing for all intents and purposes of human knowledge, it also has people sitting there helping it rank and say down to the specific linguistic level. Now, humans might say this here, but they wouldn't say that, right? So it's also encoding a lot of kind of subjective, cultural, linguistic, communicative information from people. So this is really what's going on, right? We can see the ChatGPT responses are based on patterns that it's been trained on. This isn't decision making that's happening from an internal locus of control or an internal decision making process. This thing doesn't have consciousness, doesn't have awareness or perception, right? It's also inherently a distributed thing. This calls into, it raises interesting questions about the nature of our own consciousness being in one place, right? But it doesn't have subjective experiences. It has induced patterns that the models get better and better at generalizing from. And so in that sense, it's a very powerful and cool piece of technology. But it's not, as many people have noted, a strong artificial intelligence. It's not thinking for itself. So why does this matter? Why did I make this video? Well, the first thing that matters here is that we want to know how to test for intelligence, not just the appearance of it, right? The problem here is that as these models, passing the Turing test is a trivial thing for these models. And so really what's after that, right? And there's a lot of proposals for this, how we do this. But the scary thing here is that, if something did start to achieve self-awareness or some kind of, and I think we're still very far away from this, but if something did start to achieve self-awareness, how do we measure for it? How would we know that had happened? More broadly, we see the limitations in sort of this behavioral or functional approach to intelligence, right? Intelligence isn't just the ability to seem intelligent, but what is the better solution? Another problem is that in terms of social, political, cultural, economic impacts, it doesn't really matter that ChatGPT isn't thinking, because it is appearing to think at a convincing enough level that it can replace a non-trivial amount of human generative labor, right? Whether this is in art or programming, there's not really anything that involves knowledge work, right? It can disrupt, and it can really disrupt this, we do labor, we get points, we buy food with the points, we repeat, right? This is our model fundamentally. And when this additional tool is in place where that labor is sufficiently replaced, that can lead to some really unknown consequences, right? And we just don't know where this is going to go, but this is a much more germane, immediate problem than, have we created Skynet, right? It's much more likely that we will see the replacement of some huge critical industry with thousands or millions of people employed in it than we will see a godlike AI emerge out of GPT-3. I think about those. Have you guys seen on YouTube those examples of it'll be like Full House as an '80s dark adventure, or Dune as an '80s anime, or Star Wars as a period Renaissance or something. Like, these things it's whatever you can imagine. You have a series of still images of characters that you're familiar with, but they're reimagined in a new context with a new art style. If you haven't, check them out. They're really fun to look at, really, really thought provoking. I think one was, there's a bunch that are in the style of H.R. Geiger, taking taking Family Guy and putting it in H.R. Geiger style, stuff like that. And a lot of cool technology that eventually is incredibly disruptive and kind of foundational to a new economic system. Right now, these short little videos are kind of seen as novelties. But I'm really curious, how long until these types of videos aren't just stills, right? How long is it until these kind of generative models actually can replace, to some degree, filmmaking, right? How long until entire movies can be made this way? Take this and reimagine it as this. I'm not sure that we're that far away from something like that. and that would be obviously incredibly disruptive to massive parts of the entertainment industry. So what does this do to human culture? What does this do? Not, I mean, most importantly, to human culture, but also like, GDP, right? When you can say, reimagine Kendrick Lamar as an Eric Clapton song, and it just happens, right? We start to get into this new world of art. So to sum up, I think our culture, our society is much more threatened for better or worse by models that pass a Turing test but can't really think than by models that can pass a Turing test and can think. I think we're much closer to the former outcome. My third big takeaway is, as an AI researcher, what is next? If the Turing test is really seen as kind of boring as an assessment for the reasons that I've listed, right? It's not a great assessment. It kind of is a boxing in of these models. How do we test models going forward? Outside of the one notable exception of horsepower, right, as a measurement, as sort of this vestigial holdover from the era of the horse, we don't test cars at being the best horse, right? There's some kind of echo there of what came before, but for the most part, the way that we evaluate whether a car is good has nothing to do with whether it's a good horse or not. So this is kind of the space we're in now with algorithm development and AI and machine learning, is how do we make these evaluations? I think the fourth and most important point is that as we enter a world where the vast majority of human creative, generative labor, coding, writing, art, as these things become increasingly interdependent on algorithms, at what point do we accept that we are really sharing the project of human intelligence with algorithmic intelligence? Does this kind of passing of the Turing test indicate less about, okay, these are machines that think, and more just that we have entered into a space where algorithms and humans are doing things that they couldn't have done before, they couldn't have achieved before? I think in particular about, chess, right? The best chess players in the world used to be humans, and then they briefly were algorithms. And now really it's the best chess players in the world are humans and algorithms operating together. Or return back to the example of, Dune as an 80s anime. I don't think those kinds of movies, if we get to that point where movies are kind of being auto-generated in different styles, that's not going to happen completely independently, but it will continue to intertwine human and machine intelligence. Part of this video, I needed a understanding, or I needed a brief articulation of what consciousness was, and I actually went to ChatGPT for help with that, right? It didn't write the video, but it did help put words into my understanding. It helped contextualize things for me and nail things down, and then I continued to build off of that. So I guess there's a philosophical question here, right? Did I write this? Is it all my thoughts that went into making this? In some ways, yes, and in some ways, no, right? And what this signifies is that we are emerging into a period of time where the project of human intelligence is shared. So at the end of the day, we really have two problems. We know that thinking is central to humanhood, but we're unable to define that or test for that because of our own subjectivity and because of our own ignorance of how the human mind and minds in general operate, right? We don't quite understand at the scale of our own consciousness what's happening there. That's still kind of magic to us. So there's something in the brain that we don't fully understand, and we know that this process of thinking and self-reflection, self-awareness, these are all indicators to us that we are intelligent in some way, but we can't test for it. And we also know that machine intelligence or algorithms are increasingly able to achieve remarkable things, particularly in their ability to closely mimic our own way of being. We would like to know if and when these algorithms move beyond mimicry, right, to their own generative thoughts, but we're equally as unclear about how to perform that assessment. So I think what's most interesting to me here is not that passing the Turing test signifies in some way a new era of hyper-intelligent, self-aware machines. It actually demonstrates that, not only are we unable to assess the intelligence of algorithms, we're actually, fairly unable to make the same assessment of ourselves. There's still a lot of mystery and, in some ways, magic to what defines that independent, intelligent thought, that humanhood. And this progress in algorithmic development continues to demonstrate, it continues to be a mirror back onto ourselves and our lack of understanding in this regard. So anyway, a bit of a longer video on this one. This is obviously something that I'm really passionate about and interested in, and I think it behooves all of us to get a better understanding of how this stuff is covered and kind of be able to cut between the hype and the reality, because actually the reality is much more interesting. So I'd love to see your comments in the comment section below and look forward to hearing your feedback. Thanks.